We need a recording. Here we go. So of these 5 functions, the only one we can do, depending on the rules you have, without doing anything to it before, so you can work with it, is h. H is perfectly set up for us to find the derivative of it. We can do f and g if we multiply them all the way out. And we get our 4-term cubic here for g, or our 3-term quadratic for f. But again, we have to multiply them all the way out in order to do that. And t of x, again, if you looked up the rule, you can do that one. But how can we find it if we didn't remember the rule? We're going to look at that today. So we have 2 rules. Oh, so with these, all but those 2, we have to rewrite. These 2 we have to rewrite in order to get there. We need more rules to do them efficiently and to do the other 2. So here are some other rules. Let me try that again. There are other rules, and there are several more. There's 2 more in particular I want to point out. The product rule and the quotient rule. That was fun making this one. So here's the product rule. The product rule is talking about when you have more like 2 or more functions multiplied together, how do you take the derivative of that? So d over dx means I'm taking the derivative of whatever's in the brackets. So I'm taking the derivative of f of x times g of x. The derivative of that, the rule for that, how that works, is f prime of x times g of x plus f of x times g prime of x. Now that's how it looks for 2 functions. To help see what the pattern is, I'm going to show you what it looks like for 3 functions. Notice in each of these 3 terms, only one of the 3 functions has its derivative in there. So I have f prime of x here, g prime of x here, h prime of x here. The product rule can easily be extended to as many functions as you want. And it's not terrible to find that. It takes time and effort, but it's not terrible. So that's what the product rule is. It's a rule that allows us to do this. There's a proof of why the product rule works and is this in the book. I'm not going through it just because I'm not. Probably could. I just haven't done it in a while. Quotient rule. So if product was for multiplying, quotient rule is for division. So again, if I'm taking the derivative of an expression that's a function divided by a function, here's how it looks. Now, with division and subtraction, order makes a difference. With a product rule, you could do things in kind of any order you want as long as you do everything. With quotient rule, things have to be in a particular order. Otherwise, you're going to F it up, and you don't want that. So the quotient rule then is g of x times f prime of x minus f of x times g prime of x over g of x squared. Again, you could write this another way. I write it this particular way because I try to figure out ways to memorize this and remember this. Now, you all probably like way better at remembering stuff and using it later than I am. But since I was 17, I always had a hard time remembering it in this form. And I probably work on that, and I just haven't spent more time working on it because I found something else. And I hearken it back to the 7 dwarves that helped me remember it. So if I replace this diagram with high for f of x and ho for g of x, and prime with just d, because I'm doing the derivative, hi ho, ho d high minus hi d ho, all over ho ho. So ho d high d ho, ho ho. That's my little derivative jingle. I'm not even going to call it a song. It's just a little jingle. This is how I've remembered the quotient rule since I was 17. So I could figure it out and remember it's supposed to be that way. But this is how I as I'm actively working out problems, this is how I remember it. So I'm sharing that with you because it's what worked for me. Most of you are probably more able to not need that. So good job. Way to be. Oh, hell no. I didn't come up with this myself. That was my Terminator of a calc teacher who taught us this one. She was legend. I hope someday I'll live up to her. I'm trying, so we'll see. But she's the one who helped us with this, and it just makes me laugh every time I think about this. So let me show you an example using the same two functions, but set up in different ways. Again, there's plenty of examples in your book, and I would recommend that you look at them and see how the book writes it out and talks about it as well. But here's how I'm doing it. So I'm going to let f of x be x plus 4 and g of x be 3x minus 2. Because if you go all the way back, oh, it wasn't the same ones from the beginning. Anyways, what I was going to point out is we can use product rule and f of x, so we don't have to rewrite it. G of x, we still have to rewrite a little bit, but I could just write 2x minus 7 times 2x minus 7 times 2x minus 7, which then I can apply product rule to that without having to multiply everything out. So I just want to point that out as options. All right, so on this one, product rule says I should do f prime of x times g of x plus f prime of x, or f of x times g prime of x. Well, based on what I have up here, f prime of x is 1, g of x is 3x minus 2, f of x is x plus 4, and g prime of x is 3. And for most intents and purposes, that's going to be fine. Derivative. F prime is the derivative of f, the slope function of f. So this right here is generally good enough. But this is also simple enough that you can combine that and get a simple answer. Like if you multiply out the 3x minus 2 plus 3x plus 12 is 6x minus or plus 10. That's simple enough to work out. That's fine. You could work that one out. You don't have to simplify them every time, but just know that I think there's one problem in the practice where you're going to want to try to simplify it to make the second derivative a little bit easier. Quotient rule, again, f of x over g of x. So if I set that up, it'll be g of x times f prime of x minus f of x times g prime of x all over g of x squared. Now, if I just substitute that stuff in, boom, there it is. Again, it's pretty darn similar to how the product rule is set up. It's just there's the subtraction and this thing in the bottom. This one can be simplified as well. And I simplified this one for you just because, you know, once in a while I'm a nice guy and like to enable you a little bit. So I get negative 14 over 3x minus 2 squared. I generally try not to multiply out things like this unless something's not simplifying, just because this seems slicker and more elegant to me. So that's why I choose to leave it that way. By the way, this d over dx technically means you're taking the derivative of whatever's in the brackets with respect to x. That doesn't fully make sense right now. It will when we come back to it in a later lesson. But right now, just remember d over dx means you're taking a derivative. So do the derivative and move on from there. To what part? To this slide? What do you need here? Or what are you wondering about? What do you say? Yeah. I said a kid from my 4th hour tell me, he's like, I've been trying to get into class for 10 minutes. I don't know why I can't get in. Well, you're coming in the next class, not this one. RIP. You're welcome. So, wait, don't tell me. If you've never listened to this NPR game show, you really should. It's a great use of like an hour in your Saturday mornings. So there are derivatives of tangent, secant, and cotangent and cosecant. which a lot of you have. Yes, it's so good. Oh my gosh. I used to spend a lot of time listening to it when I worked at Menards, because it happened to be playing when I was coming back from my shift. So I got a lot of good time just listening to this. It was so good. Anyways, the derivatives of tangent, secant, and of those four, we can figure out all those derivatives by rewriting each of them in terms of only sine and cosine, and then applying the quotient rule to them. Yeah. So that's why I was saying that we didn't maybe know what those were right at the moment, but we could figure them out. That's why I didn't intentionally include those ones with 2.2, because I wanted to point out the fact we could derive them. We could show what they are. And I would recommend you try doing that. I think one of the homework problems is also on that. So keep that in mind. Alexander Meerkat believes in you that you can do that. That's all I have for you. So here's the practice. It's due soon. Again, make sure you read the section. There's also information about second, third, and higher derivatives. Basically, what that means, a second derivative is the derivative of the first derivative. So to get there, you do the derivative of the first subject, of the first function, to get the first derivative. Then if you do the derivative of the first derivative, you get the second derivative. So like of x squared, the first derivative would be 2x. The second derivative would be 2, because you just took the derivative of 2x. So that's what that is. Now, this said, I got about 7 minutes left. And instead of just letting you go early up, I'm willing to answer just a couple random questions for you. Is there any particular questions that you want to talk about or me to just kind of free ball on? Got it. You see my face? Nope. I want it the other way. Like that. Hey, look at that. Cool. So we want a number without a variable. Yeah, and I can do some 2-2. So, let's see. I'm trying to figure out, is that visible? No, well, now I can't see because I came all the way over here. All right. Make that nice and large. Let's see. You can kind of see stuff. All right, let's see how this works. So the derivative of any constant is that working? A little bit. Is always 0. Because if you think about it, just a moment. There we go. if I try to draw a tangent line right here, the slope right here is 0. So that's why the derivative of any constant is equal to 0. All right, this is really not the way. I think I'm more likely to just do this. Yeah, the derivative of a variable is always 1, because as long as there's not a number in front of it. Because if you draw that equation, the slope at any point on here is just 1. But let's say I did the derivative with respect to x of 3x. Well, it's going to be 3. It's just more of the same there. Why is the derivative 3x? 3. Kind of a similar thing here. If this is y equals 3x, again, the derivative is a slope function. So at any of these points, at each of these points, the slope is 3. So it's always going to be that. Now, to justify it, other than just graphically, if we use the definition of the derivative, and I'm just going to use h because I feel like it, of if I use 3x for this, simplify it a little bit. Those kill each other. And then this is the only thing that's left that simplifies. There's nothing else to kill off. So it's just 3. So here's graphically why the derivative of 3x is 3. And here's algebraically why the derivative of 3x is 3. And 2.273. Let me hit that real quick just to talk. Oh, okay. So for 73, you're using this setup. So your initial velocity is 120. So that's your v of t. And it's from the surface of the Earth. So your initial position is 0. This is your position function. In order to get a velocity function, you need to take the derivative of position. If you go and look in this section, right here, velocity is the derivative of position. All right, so that's how you can find that. And if you see this one down here, they talk about, well, here's the position function. Here's the velocity function. Oh, sorry, it turned off, my bad. Yeah, my screen went black for some reason. But that's what, so that's how that one works. Again, velocity, if you look on page, where's the page number? 109. Velocity is derivative of s, so s prime of t. So to find the velocity, I think you just have to basically find the velocity function. Yeah, and then just plug in 5 and plug in 10. That's all. All right, with that note, it's a minute after, so I'm gonna get ready for my 4th hour. Oh, the last thing I was gonna mention to you, I mentioned to some other folks earlier. Today at 3 o'clock in Discord, I'm gonna I'm gonna be in the general voice channel. So if you just want to drop in, ask some questions, I was planning to stick around till about 3:30. If after about 10 minutes, no one's there, I'm gonna probably leave. I'm just trying to add some extra things just to see if I can help you folks out at all. Oh, my camera is still off. Oh, when I'm looking at the chat, the camera went off. My bad. That makes sense. So that's what I have for you. Yeah, so if you want to drop by later today, again, around 3 o'clock in what's called Discord, I'll be in the general group chat or the general voice channel if you want to pop in and ask some more questions, and I'll answer what I can, just kind of that, or just kind of generally shoot the breeze. Prioritize math, but we'll also shoot the breeze if people want to shoot the breeze. That's all I have for you today. Have a great day, folks. We'll see you later.